Hello guys, this is Charlene Cheng. Welcome to week 1. In this week, we're gonna mainly talk about the introduction of data analytics and data science. There are several things that data scientists do. Firstly, finding out what the question is about. Secondly, preparing text and data. Thirdly, taking a look at the data. Fourthly, predicting how much. Fifthly, predicting yes or no. And sixth, testing it. And last, playing with what if. In this class, we're gonna mainly focus on step 4 and step 5, predicting. To do predicting, we have to use several different models. Typical model. A typical model in data science is an attempt to relate one set of variables to one another. Predictive analytics. It is a data science, a multidisciplinary skill set essential for success in business, organizations, and government. Firstly, supervised and unsupervised learning. In supervised learning models, the supervisor is the target variable, a column in the data representing values to predict from other columns in the data. The target variable is chosen to represent the answer to a question to the organization would like to answer or a value unknown at the time the model is used that would help in decisions. Sometimes, supervised learning is also called predictive modeling. Unsupervised learning, sometimes called descriptive modeling. It has no target variable. The inputs are analyzed and grouped or clustered based on the proximity of input values to one another. Each group or cluster is given a label to indicate which group a record belongs to. Secondly, parametric or non-parametric models. Parametric algorithms or models assume known distributions in the data. Many parametric algorithms and statistical tests, although not all, assume normal distributions and find linear relationships in the data. Machine learning algorithms typically do not assume distributions and therefore they are considered as non-parametric or distribution-free models. 3 approaches. There are 3 general approaches to research and modeling as employed in predictive analytics. First, traditional. The traditional approach to research, statistical inference, and modeling begin with the specific of a theory or a model. Traditional methods such as linear regression and logistic regression estimate parameters for linear predictors. Model building involves fitting models to data and checking them with diagnostic. Second, data adaptive. When we employ a data adaptive approach, we begin with data and search through those data to find useful predictors. Data adaptive methods attempt to use those available data, representing nonlinear relationships and interactions among variables. Data adaptive methods are data-driven. Thirdly, model-dependent. Model-dependent research begins with the specification of a model and uses that model to generate data, predictions, or recommendations. Simulations and mathematical programming methods, primary tools of operations research, are examples of model-dependent research. When employing a model-dependent or simulation approach, models are improved by comparing the generated data with the real data. It is often a combination of models and methods that work best.